Welcome to Session 6, Ratios, Proportions, and Chained Relationships. This lesson develops mathematical reasoning that stays reliable when a problem looks unfamiliar. You will learn to combine chained ratios to distinguish direct and inverse relationships and to preserve labels and units. These are connected habits, not isolated tricks. Keep a pencil ready. We will build a mental model, use a repeatable method, solve a demanding example, diagnose an error, and finish with an independent checkpoint. Start with this principle. Ratios are multiplicative relationships with an order. Use this visual structure. Match shared parts is greater than Bill-Doan ratio is greater than Apply scale. Read every symbol and label before calculating. The first goal is to combine chained ratios. Connected to the second goal, distinguish direct and inverse relationships. Correct calculation begins with correct interpretation. When the surface details change, search for the same relationship underneath. Transfer means choosing the structure from evidence, rather than waiting for a familiar-looking example. Step 1. Write each ratio in labeled order. State the target and preserve its units or conditions. Step 2. Match the shared quantity. Use a separate line so signs, factors, and labels remain visible. Step 3. Scale all parts consistently. Keep the reasoning efficient, but never skip an operation that could hide an error. Step 4. Check every original relationship. Verification is part of the solution because it tests the answer from another direction. Signal 1 is A total is split in a ratio. Respond by remembering, add parts, then scale. Name the response before calculating. Signal 2 is two ratios share a term. In that case, make the shared term equal. The form tells you which tool fits. Signal 3 is a fixed product is described. Remember, model inverse variation. This separates plausible work from valid reasoning. If you cannot name the signal, pause and classify. A deliberate choice of method is usually faster than repairing a rushed setup. Here is the challenge. If x varies directly with y and x equals 18 when y equals 6, what is x when y equals 10? Restate what is requested before touching the choices. The first move is write each ratio in labeled order. Apply it directly to the quantities and conditions in this problem. Now use the core reasoning. The direct constant is 18 over 6 equals 3, so x equals 3, 10. Keep each equality, comparison, or unit conversion visible. Pause for a midpoint audit. Check copied values, signs, units, restrictions, and whether the current result is the requested quantity or only an intermediate value. Continue by applying this control. Scale all parts consistently. The explanation supports one option without relying on its position. The mathematical conclusion is 30. State it with any required units, interval notation, or restrictions. The final answer is 30. Compare it with the exact target and reject any choice that represents a common intermediate step. Verify from another direction. Substitute the scaled values into every source ratio. The check should use evidence independent of the original calculation whenever possible. Try this checkpoint without copying the example. Why must units remain attached in a proportion? Decide which mathematical fact controls the answer. Pause and write one line of reasoning before committing. A visible decision is easier to inspect, explain, and correct than an unsupported guess. A focused hint, unit labels expose reversed or mismatched ratios. Use the hint to repair the setup, then finish the reasoning yourself. The accepted answer is, they reveal whether corresponding quantities are aligned. Explain why it works, and name the earliest line that would reveal a likely error. The central message is to combine chained ratios. Combine that with the discipline to distinguish direct and inverse relationships. Finish by remembering to preserve labels and units. A result becomes dependable only when the method and verification are both clear. Reflection. Where could reversing a label produce a plausible but wrong result? Name the exact point where an incorrect path would first become visible. Practice one fresh problem for 8 to 12 focused minutes. Keep the work readable, verify independently, and carry the routine into the next session. Before moving on, close the notes and explain the method aloud from memory. Then invent one small variation, predict how the answer should change, and verify that prediction with a complete calculation.